So this class is going to be an introductory class for a class that you guys are going to have in your junior year. So it's going to be very hands-on. But even though I like things that are hands-on, we have to actually have you guys doing some work on the background as of like how things work. Because if I go there and I do it, you guys are smart. You can go there and do it right away, right? But you can't do it next semester. You guys are gonna forget. You know, that's how the brain works. So this class we've been trying to do it different ways. And then what I thought like it would work best is actually just like any other class from kindergarten. You know, you do like a flashcards of like a addition. You have 1 + 1, 2, 1 + 1, 2. Like you do several times the same thing, right? So we went from doing a lot of different things to doing the same thing 3 times, right? So you can get better at it. So then like next time when you come back, you'd be able to do it again, right? Because what we noticed is actually a lot of the students, they would be able to come, they would do the whole class perfectly. Next semester when they're gonna use the equipment, they'll come and they wouldn't even know which equipment we have. It's like, you've been here like, now it's gonna be 4 months ago because we're gonna have the whole summer, right? But sometimes there's only the Christmas break and people wouldn't remember, you know? So it's kind of tricky, you know, this hands-on things, you know? If we keep doing every day, then we remember, but otherwise we won't. So we're gonna have this bureaucratic part that we're gonna do along with the hands-on, right? Also, this class is gonna be a very weird setup. So we can actually give the students a one person on each equipment per slot, right? So for example, I can go back into, so if you open our Canvas page, I'm gonna go and view as a student so I can see what you see. If we go into home, that's what we have. If I go into link to tentative schedule, that's what you're gonna get. And when you come in here, so this is a file that I have on my computer that I have everything that we're gonna do every day, right? So today is January 8th, that's lecture 1, right? So this is the only way that we can have this weird setup and we're still gonna be able to manage the communication. You know, otherwise everybody's gonna be lost. So, for example, how is this weird setup? It is like this. First, so like after the lectures, we go in there and then the professor is gonna do all the work and tell you about the equipment and make the cuts. I'm gonna cover the welding part. Dr. Haddad is gonna cover the vertical mill, and Dr. Batterai is gonna cover the lathe. So he's gonna go and we're gonna give you a drawing and say this is what we're gonna cut, right? So we know that what we're gonna cut. He's gonna explain to you the equipment, how to use it. You raise your hand, you take notes, you ask questions. And then that's the demonstration day. Following day, we are gonna split the groups into student 1, student 2, and student 3 because we have 9, so we're gonna have 3 stations, 3 students per station. So on this day, student 1 and student 2 are gonna come, but they're not gonna come at the same time. Student 1 comes for the first 30 minutes of the lab. Student 2 comes for the second 30 minutes of the lab. What about student 3? Is he off? No. he has stuff on Canvas that he can go and watch, read, take the quizzes and stuff, right? So pretty much it's gonna be, everybody's gonna be doing stuff, right? But sometimes they're gonna be doing hands-on there in the class. Sometimes they're gonna have to sit down and do the stuff on the computer, right? So this way, whenever, let's say, student 1 comes in, the equipment is all for student 1. The equipment is not going to have anything on it. The student has to go, grab the collet, choose whatever end mill the student wants to use, put it there, put it in. Because if we're sharing the equipment, what happens most of the time is student number 1 goes there, grabs some stuff, put it on. Whenever student 2 is going to jump in, guess what? It's already there. So the second student doesn't have the chance to actually do all the work. And actually that's when so it's fair that a guy will come in and say, you know, I actually never had a chance to put the tool in, so I don't know how to do it. Yeah, because you get some work already done. So the way that we're going to do is you have 30 minutes to do your work, and whatever I ask you to do in 30 minutes, I have to be able to do it in 10. So you guys have 3 times more time, because it's not that things are difficult. It's simple things. It just takes time. It's just because I've done so many times that I know where the tools are, you know. So if you say, okay, now I need to grab this one tool, I have to go in here, I have to do this, you know. It's you take a little bit more time, right? To help on this pace, you guys are gonna have to write down everything that you're gonna do before coming to the lab. So how come? How am I gonna write everything that I'm gonna do? Let's see. How many people here are athletes? So softball. Swimming. Plays. So let's say, man, I was hoping a football or something. No, let's say there are some plays that you don't have to be in the game to envision it, right? The guy's gonna say, I'm gonna run a 10 yards front, a forward, then I'm gonna turn left, turn right, and I'm gonna go back. And so all these things you practice up front, and then what? When you do it in the game, it's automatic, right? So you actually gain a little bit of time by doing that, right? So that's pretty much what we're gonna do. In previous years or previous iterations of this class, we only had 2 lectures in the beginning here. Oh, wrong computer. We only had 2 lectures here. I added a 3rd one so we can try to cover this step-by-step thing, right? Because thinking up front actually helps you in life a lot about anything. And mechanical engineers, there's one of the fields that you guys can go is actually into processes in a factory, for example. And then you have to create a process that somebody else is going to use. So then you have to create a process that's actually efficient, right? That doesn't have a lot of waste, that doesn't have a lot of reservice, you know. So these all things that we can exercise by doing this, right? So I don't know if you guys are transfer students or if you guys have been here for or freshmen have been here since last year, but each of us from the faculty, we're always going to throw in our experience into the class. So if you guys had class with Terry, he's gonna throw a lot of his programming experience into like what the class is. So the class is not really 100% about that one subject. Is that subject plus the professor's experience. So like I'm trying to throw in a little bit of my manufacturing experience, even though I'm an electrical engineer, into like what I can see that in the future you guys can face, right? So this process part, I think it's important for mechanical engineers. So I think like it's a valuable thing for you guys to learn. So yeah, today is boring day, so because I have to go through all this stuff, right? So I'm gonna split the names at some point, and what's good about this setup is that, let's say you're gonna say, man, I'm gonna be traveling because we have this regionals happening. That's fine. You just look at your name here. Can you come on the next day here? Yeah. So you can talk to your friend, and you guys can switch, and then now you know that you're not gonna have to be here in that day. Okay? So as long as we keep an eye on the tentative schedule, as long as we communicate, then it's gonna work out, right? And if you look here, and you're like, my name is not there, then let me know, because I make mistakes too, right? It's a lot of lines, and I have to go between like, okay, who did this, who did that, and like keep messing up with the spreadsheet. So it's very likely that I'm gonna make mistakes. So if you see anything that's wrong, if it looks like it's wrong, most likely it's my fault and it's wrong. So you can blame on me. I don't, that's what my wife does all the time. So all right. So let's go back into the modules here. So I'm recording the same way that like I recorded for other classes, right? So if you go into meeting number 1, that's today. I'm gonna have the video there. So this is the video and the jokes from 2024. So they're old jokes, So, but like you're gonna find the syllabus right there. We're gonna have shop procedures. We're gonna talk today about machine tools, safety, and some lab procedures, right? So this is what we're gonna cover today, right? And then I'm gonna open the quiz, and I'm gonna say complete the following quizzes, and they're gonna have the quiz there that you're gonna have to complete, right? So if you come in here, quizzes, and then safety and shop procedures are gonna be there. Good? There's one problem with that. 3 people are gonna be doing the lathe, 3 people are gonna be doing the mill, 3 people are gonna be doing welding. And then we're gonna do demonstration, exercise 1, exercise 2, exercise 3, rotate. Right? So pretty much all the modules are gonna be open. Which module do you have to do? You have to know. Some of the students in the past, they're like, man, it doesn't show on my to-do list of the day. Yeah, but like if I put a to-do list, like everybody's gonna be due on the same day, right? It doesn't work. Or some people, they say, yeah, like do that anyway. And then now, if you didn't complete the stuff, your grade is gonna be 0. And then people are like, oh, my grade is 0. So yeah, it's like it's because like it does like this is a different setup. It's not like a regular class, So I'm not gonna put due dates for anything. You have to know that if you have to know that like if you have to be there on exercise number 1 on January 22nd, you have to have already the step-by-step done before that, right? Otherwise, it's gonna be difficult for me to grade and give it back to you and say, oh, this is good or this is bad, And then this becomes like a big snowball, right? So it looks like a lot of work, but because some days are gonna be off, that's what we're gonna be doing in those days. It's just gonna have like a whole hour to complete, plus that 1 hour that you have to do like a homework for this class, right? It's a 1 credit class, so. And at the end, let's say at the end of the module, let's say you worked on the lathe, right? So what I wanted to do is at the end of the, like I'm done with lathe. You're gonna end up with a report, and the report's gonna have the introduction is gonna be like your own operations manual for the lathe. If you look at operations manual, it has too much stuff. You have to sift through and see what's important, what's not, right? What I want you to do is actually you go there, you are gonna take a picture of the headstock of the lathe, and you're gonna say, these buttons are just this, and you have the arrows, and then when you have to use it later, then you know, and if you don't remember, you can go back to your own document and you know, right? And even better than that, usually if you write down the stuff, guess what? Usually you never have to read it again, because that's how you memorize it. If you do stuff you never wrote down, there's a high chance that you're not going to remember. That's how the brain works, right? Like I remember when I was a student, I used to write everything down. I would never read one of my notes because I always remember the notes. I remember which corner of the page I wrote. But like the idea is, the day that I was like, I don't care, I wouldn't write, and guess what? I don't have a clue, you know. So we're gonna try to use these techniques about doing 3 times the same exercise, different numbers, same exercise. Write things down so you memorize. And then the work that we're gonna do, that means like you're gonna do the introduction, which is like an operations manual for you. You're gonna do the step-by-step. That's gonna go into your report. So your report's gonna be stuff that are all your deliverables is gonna go what? Is gonna go into your report. So some people they ask me like, how many pages is the report? I don't know. It depends on this, like how many pages your stuff that you deliver before or have, because they're just gonna pretty much attach everything. You know, there are a few things that are gonna write, like what went wrong and what went right, but like otherwise all this stuff is actually stuff that you've already done. You know, I'm not asking you to do it again. So. And as you guys know, is anybody transferred just transferred to UMary this semester?
I was here like a year and a half ago, and then I just transferred back.
So you guys know that are gonna be writing this in LaTeX. So otherwise, if you don't know LaTeX, we can help you guys out with it. But all right, any questions? I know there's a lot of questions, but like
I don't see the course in Canvas.
You don't see the course on Canvas. That's a good question, you know. Oops. Not the day. Access denied. Yeah. Oh yeah, it's not. It's published now. Try again, drummer. All right, let's go on here. All right, Michael.
Here.
Olivia.
Here.
Brady.
Here.
Jeremy.
Here.
If I say your name wrong, correct me. If I keep saying wrong, maybe I can't say it right. But like I'm gonna try my best. Caitlin.
Here.
Anthony.
Here.
Aram. Is that how you say it?
R.
Aram. Okay. Joseph.
Here.
Joshua.
Here.
Did your brother go to school here?
No.
No. All right.
It still says it's not published. I think it's under course status on the very right. It says unpublished. I don't see
The
it.
course itself is not showing up on campus. It's not the stuff, it's just
You're right. See? Good stuff.
There we go.
There we go.
Yeah.
See? You know the good thing about life is that like everybody makes mistakes. So when you make a mistake, it's fine. That's the. Yeah, some people they punish themselves for that. It's like, yeah, you should take it easy.
Just keep that in mind when you're grading.
Yeah. Yeah, and actually that's a good point. So the way that I grade is it's gonna be like a hard, and then I get the first student and I put it 100. You understand? So if I say I'm gonna make it easy and everybody gets an A, then we lack into actually how far can we go, If we say let me do it the right way, and then you guys are gonna be, let's say, 92, and then the 92 is gonna become 100. So it's fine. This guy was the 100% in the class, right? Because I think that way we can push people further than they can go, right? Compared to let's go to the gym and everybody grab the 5-pound weight and let's do it. That's like how the other schools does. All right, so let's see. So what did I say that I was going to cover today? That was weird because I actually on purpose put on the student view, so it'll give me an error if it wasn't published. But see, it didn't give me an error, and I could see the stuff, which is weird. But it happens. All right, so we have the syllabus. So I'm still editing the syllabus, and I'm gonna make it available for you guys. We're gonna have to decide together how much does the stuff is gonna worth. How much does the hands-on work is gonna worth as of a weight on your grade, right? Because it's simple, but it's easy to make a mistake, right? You forget to zero the equipment, you cut more, you cut wrong. You put your piece there and your piece is a little bit like this, it's off, right? So usually we start and everybody, let's put 100% the grade on the hands-on. And then was can we change it, because it is something that we need attention, and that's why the goal is actually to have a good step-by-step written. So when you go there, you're okay, I'm gonna zero here, okay, zero there, I'm gonna do this, okay, right? And even sometimes we're gonna actually even throw in the numbers on our step-by-step, even though the numbers are gonna change a little bit. just so it gives us an idea, you know. And I usually have like a big scratch paper, like by the mill or the people on the lathe. Usually I have them writing on the glass. So they do the math there. They say, I'm gonna cut 100 thousandths here. And I tell them, you know, we don't have to, you know, we can say, let's say, we're gonna go from 1 inch to 900. Is this easy to think? Oh, this is pretty easy. Like, why did anybody write this down? And then I do this. Okay, so we're gonna be at 100. So this is how much I'm gonna take out. Because now when you go to the equipment, and you have to think, oh, this lever is gonna be here, this lever is gonna be there, this is gonna be here. Which number should I use? And then people look back, and all the numbers are like this. And which number the person uses? The 100 instead of the 900. So like little mistakes like this is actually what's gonna make it wrong. So the thing is, I tell people, you know, it's not bad if you're like, you know, this is the one that I'm gonna do next. Oh, I measured and I got like a 0.895. It's like these are all notes. These are all notes. Like nobody's gonna judge your notes, you know. So I encourage you guys to use this kind of stuff. And actually, the guy that helped us set up our machine shop, he said, like he was a machinist and welder for his whole life, and he's like, if you take the scratch paper from the machinist, he can do the work. Because he's always taking notes and he writes down exactly what he's going to take. Because now when he looks at the equipment, because you have to be focused here for the equipment, you have to be focused there for the number. So whenever you move from this world to that world, you lose that one. And then now when you look, you're like, what should I do? You know, because you're too focused on this, you know. So like this is actually something that's, it looks kind of like a stupid for a lack of a better word, but like it's not, you know. It's how people would do all the time. All right. So most likely I'm gonna post the syllabus later, so you guys can have like a more accurate way of doing it. And these days, like the syllabus become pretty much just like a policy thing, you know, more than. All right. And a lot of what we did here, what we're talking about, is a lot of what we're talking about is going to be on the presentation too. So I guess you guys have been here for a while. You guys know that when you get to the machine shop, there are like those slots for you to put your backpack there. So whenever you come in, you gotta get your stuff, put it all in there, and then on the demonstration day, you're going to bring like a notebook, something to take notes, right? On your work day, you're gonna bring your step-by-step and a pen, right? But everything else is gonna be outside. Can I bring a water bottle? Yeah, sure. You know? So we're gonna start the backpack. We don't have cell phone use, even though we're gonna use cell phone for the class. So like you're gonna want to come and take pictures so you can add to your report, right? But like we're not gonna post a video on Instagram. I was like, so we're gonna have like a good use of the cell phone in the class. So in the past, it was a different setup. It was like everybody would be there at the same time. Imagine like 9 people plus the 3 professors at the same time in there. And it gets crowded, you know. The lathe is here, the mill is here, you know. So there was a lot of horseplay, which is not a very safe thing to happen in a machine shop. Because if I push the guy here, what happens to him? He hits the next guy, and the other guy is right on the vertical mill on the other side, right? So now with only one student and the professor, you're going to be doing all your work, and the professor's going to be like, no. But the professor's just going to be he's going to allow you to do this stuff. And in case you're going to do something that you should have said, no, this is how you're going to do it, right? Exercise 1 and 2 is more for you to learn. Exercise number 3 is actually the one that we're going to evaluate you, right? So the first day, we give you the chance, we tell you guys everything. We're still going to take notes. Second day, we're going to, again, help you around. We're going to take notes. So your performance usually is worth 5 points. Third exercise, your performance is worth 50 points. Because then we've been working and we don't have any more time. You have to pick up, All right, no food allowed. The professor is allowed to break the rules. So we're not going to use compressed air to clean any of the equipment, right? So people only think about the compressed air, about the hoses, than the equipment that we. But I don't like when people go on stuff. If one of those a metal shavies get in your eye, you're out for the season. You're not gonna once I was working here, a little piece of so I was drilling, and then it went, and then a little bit of the sawdust from the drilling got in my eye, and I was wearing a safety glasses at the time, but the safety glasses is not it's not a snowboard glasses, So it went on my eye, and then I tried to clean it. There's the face washing thing there, and then it seemed it didn't get out of my eye, And then I had to go to the doctor, and then when the lady zoomed in, there was a huge cut on the eye. It's just from the thing getting in there, and your eyelid comes down when you do this the first time. Then I couldn't see for I couldn't stand in light for 3 days, So it's it's a pain. So to avoid that, we're gonna try to be safe, We're always gonna have the glasses, but we're never gonna try to go blow into stuff, And we're not gonna push with the compressed air. So we always have some brushes that are just gonna clean up the stuff, right? So the personal protective equipment is always required, and which equipment is required may change. So you guys are gonna learn about that. Machine shop attire. We always need closed shoes, right? We always need pants, long pants, and our clothes cannot have any loose ends, so I have to tuck in. If we have long sleeve, it has to be folded, not pulled. So if our long sleeve is like this, we can't just do this because it's gonna go back. So some people sometimes they have some long sleeve that are so tight that you can't do this. Then we're just gonna have to go and change and come back, right? And let's see. I think we're gonna get at some point, but long hair, that's always a big concern in a machine shop. So we're gonna try to understand well how we're gonna go about being safe around it. Okay. Bring any concerns to me or any other instructor that you were going to have in there. Structure supervision is always required. At some point, I'm going to understand how much you know. And then I might say, yeah, just do the work, and if you need me, you just call me. Because I understand that you're proficient at using the equipment, right? And then I'm just going to be listening to the work, and then sometimes the machine does noises that I know what they are. I say, is everything good in there? Yeah. Training is required to operate the equipment. Attire, closed shoes, pants, long hair had to be tied. Long sleeves had to be folded above the elbow, not pulled. Shirts tucked in. No rings or bracelets. So the thing about the rings and watches, you can wear a watch if the machine catches into it, it's gonna rip, right? If it's a watch that if the watch gets sucked in, it's gonna suck you in with it, then it's not good, right? So usually, I used to work in an offshore rig, so they'll say, you can get some bands that are very fragile, and then I could use a watch at work. But if it was a band like a metal band, then I couldn't, right? Because sometimes these extra things that we add makes it a worse condition for us. Like for example, imagine you have a ring and then something hits your finger. But imagine you have no ring. Something hits your finger right there. It's gonna hurt, right? Now, imagine you have your finger there with a ring. Something hard hits it. It chops your finger off. Or let's say you bend the ring and now be running around to find something to cut the ring, otherwise you're gonna complete there's not gonna be blood flowing through it, and stuff like that. So usually we try to take all these things. Can we break the rules? Yes, we can always break the rules. The engineers are usually the guys that have to break the rules, because they're the only ones that can do it, I don't know if a few years ago there was a tsunami in Japan. I don't know if you guys remember that, maybe some 10 years ago. And then there was a nuclear power station that started leaking there. And then nobody would say that somebody should go in there, Who was sent there to fix it? The engineers. So you're all can you work breaking the rules? A lot of the times you're going to be asked to work breaking the rules, but how you should work to still be safe, right? Because you know the boundaries, right? All right. Protective equipment. So we're always going to be using safety glasses. If you have your personal special safety glass, you can bring it. Otherwise, we have the safety glasses there for you to use. Right? The safety glass has to be used at all times for some flying objects and stuff. Or if somebody is welding back there, some of the UV rays that are generated by the welding just go bouncing around. So if you don't have your safety glasses with this extra, that it has a UV coat, you're going to be actually absorbing that, And sometimes, depending on where you're working and how many people are welding and all the condition, you might have your eye starts getting sore, So we're always going to be using safety glasses. So we have dust mask, face shield, gloves, and that's going to be based on what equipment you're using. Some equipment you need gloves. Some equipment you can't use gloves at all, right? Why? Because let's say you were You're welding. Do you need gloves? Yes. You get your piece that you're welding. You go back to the grinder. Should you wear gloves? No. But now you have to understand, is my piece hot? Maybe. So like I see, like there's like because you're doing the work, and you are gonna be doing the work. I'm just gonna be walking around and watching you to see if you can do it, right? Because all this, it's all a packet, you know. Either you can do it all or you can do nothing, you know. It's all part of the same work. So all these things we're gonna actually experience, you know. And right now it looks like a lot, but you're gonna see just like anything in life, it looked difficult and then all of a sudden it was fine, you know. So pretty much we're gonna have everything for you guys there. So like on the lathe and the vertical mill, we have no gloves, hair tied. We have hair nets if you want to use hair nets there. The welding booth, we have the auto darkening face mask, the welding apron, the welding gloves, the chop saw, the cold cut saw, and the grinder. We don't wear gloves, but we have the face shield there to use. So how do we go about safety? As people first all the time. If everybody's safe, now we try to save the equipment, right? So people first, equipment second. And you have to worry about you, and you have to worry about everybody else too, right? So personal protection. So if you have any health condition or some ongoing condition, in this presentation when I got, it was from the 80s. So it was if anybody was drunk or something in class, that usually doesn't happen here. But sometimes let's say you took a medicine that makes you drowsy, maybe you shouldn't be going work in the machine shop that day. You know what I mean? So or I don't know. I've been up for 30 hours because of this other thing, you know. Let me know. We're gonna work with it, right? It's better not to do it than to get hurt, right? And we're pretty good at actually working stuff with you guys. So before ever use, inspect the equipment and see if there's anything wrong with it, right? Sometimes you gotta inspect even more than once. Let's say you set up your equipment, you come in, you inspect, everything is good, you set it up, and there's yeah man, I have to go to the restroom. No, but I say, I'm running out of time, I forgot I have a class. Can I come back after that class? Yes. So you go to class, and then 15 minutes later you come back. Is the setup still there? Maybe not. Maybe some other student needed to do some quick work. They came in and set up and it changed. So pretty much every time that you come in, it's just a quick look to see if everything is okay, right? So we have to check for guards. Sometimes the guards are not there, but then we're gonna understand what needs guards and what doesn't need guards, right? And you inform anything that if you think that needs attention, let me know. Sometimes I'm gonna say, yeah, no, that's fine, that's how it is, right? But tell me, machine shop maintenance. So when we come in for the work, all the tools are going to be nicely laid there. And I put a white piece of paper and I trace the tools so you know exactly where I should go back, right? And it's you, not your professor, because if I had to come with a saw and bishal, all tools are going to be all over the place. So I have to count on you guys to put it back. So you start, all the tools are there, you get all your stuff, you do the work. At the end, guess what? You disassemble everything has to go back. You clean up at least what you see that you did, and then you're off, next student comes in. Good? Close all cylinders, that means only for welding. And clean the space after use. So each person is gonna kind of like clean up their own share, right? Any questions?
Can you put this presentation also available on Canvas?
It is. I click it on Canvas. It's this one. Meeting number 101B.
It's published now, I think.
On the meeting number 1?
I don't see it's in files?
No, it's on meeting, so I go to modules,
Oh,
meeting number
I
1
see. Thank you.
is the
Yeah.
second one.
Yeah, thanks.
Jeremy?
So do we clean with the compressed air or not? Do we use the compressed air to clean?
No.
No.
So we're just gonna brush it off.
Fresh, okay.
The other reason why we don't use the compressed air is because like, I don't know if you noticed, but like usually the equipment vents, they face down. So if you look at the vents for the equipment, they're like this. Do you know why? Because gravity always pushes stuff down. Gravity doesn't push stuff up. If you have a piece here and you push with the compressed air, guess what? If it goes in the motor case in there, piece of metal, it's not going to be good. It may not be, like it may not affect at all. It may affect it. So, all right. So I'm gonna have you guys. No, we don't do this anymore. So I'm gonna have one document like this in class. So you guys are gonna take one, and you guys are gonna sign one. That's pretty much all that we're talking about. Safety glasses, like it's pretty much all the fine print. It's like, we told you guys about this stuff, right? That you shouldn't break into the machine shop over the weekend, it's all in here. We bought a long hair. If you guys are injured, what you should do, so you guys can read through. You guys are I'm gonna bring for next class. You're gonna read one, sign one, keep one. Okay? But it's here if you guys are gonna see ahead of time. 20. Machine tools. All right, so the tools that are going to be working, usually we have those tools at home too. So if you say, what's the difference between a drill press and a regular drill? Or let's say a sawzall or a hacksaw compared to a power saw, or a grinder with a angle grinder. The big difference between this equipment and the ones that we have at home is the trigger. All of them are trigger, you actually have to push the trigger. Something goes wrong, release it instant, right? These machines, if you get caught, by the time that the person pushes the button to stop, it's already done. Everything is going to be rotating at 2,000 RPMs. Everything's so fast. So we have to make sure nothing goes wrong, right? We don't get paper cuts in the machine shop. So and usually all these tools, you're like, what is this thing shaking like that,
It's been doing that this whole time.
Yeah, like that.
I suspect it's the fan is slightly imbalanced, and so
Yeah.
so often the resonance builds up.
So all this equipment, if you think they're all stationary, they're power driven, like there's an engine or something that's driving them all. They're metal cutting, but they don't have to be. But one thing that they all have in common is that they're all based on a rotating equipment, right? How come? Let's say a drill press. What's a drill press? You have the chuck there, right? You rotate the chuck, you have the drill bit. So up here you have the motor, you have the belt to transfer the power. So this is a rotating power, right? That's a drill press, you drill it. The lathe. I don't know if you guys know what a lathe is, but you have a chuck, you hold your stock with the chuck here. Your stock rotates, and then you bring your tool, and then you cut it. The rotating power right there. Power saw. How is the power saw rotating? One, we have two kinds of power saws, right? One, it's a belt one, and it makes sense, right? The belt goes around, and then it cuts whatever. So even though we don't see it, this is covered. If something gets caught here, what happens? It gets dragged into the pulley, and then what? And then it's gonna suck you in, right? So all this equipment, they're all based on a rotating power, right? So that's what makes them, like how we can actually say, oh, these are machine tools. Even though there's a lot of machines and tools, but this is what we call machine tools, right? So the drill press, the one that we have is what we call a sensitive drill press, because you have your arm there, and when you're drilling, you can feel it. Is it going well? Is it not going well? Is it like bouncing around? Is my feed too fast? Is it too hard? So you can tell by just holding it, you know. Ours is a pedestal one. That means it goes on the ground, right? Or it can be like a bench top. So ours is pretty much like this, but this looks more like a tabletop one. The lathe. Where is that? There was a nice. I have to put it back here. Okay. The lathe. Ours is a gearhead lathe. That means we have a motor in here, a DC motor in here, and then all these gears that you can change, just change the gearing system so you can adjust. The speed here is the same. There's only one button here that actually changes the speed here. But the relation between this speed and the speed of your chuck there sometimes is adjusted by the gears that you choose there, right? Or the rotation of your gear, of your chuck there, has a relation to the auto feed of your Y. So that's also adjusted by some of those gears there, right? So you have a gear head here. So it's all based on gears, right? Now you can tell why the other option would be a belt driven is because you had to open this side and change belts. It's interesting because if you guys, can you change the speed of your drill press?
Some of them you can open the top. And
See, you can open the top and you have a belt in there, and you can change because you have different size pulleys in there, right? So in the past, the lathe was actually belt driven too. So now they do with gears. So we're talking about the saw. We have actually two bend saws, right? In the 2 horizontal bend saws in the machine shop. The other option would be a power hacksaw. The power hacksaw just goes like this. It keeps doing that movement, right? So there it is. It's just like a straight blade that goes like, and all have a rotating motion, right? You have something here and something going. Milling machine. So the milling machine that we have is called a vertical milling machine. That means our tool is actually vertical and our stock is here, and then you move the stock around. So the tool rotates and the stock moves around to get cut. Right?
How does the horizontal work?
The horizontal is just like your tool is being held like this. Sometimes you can have another, yeah. So it's just like the direction of the tool. See, this one is trying to hold things like this, and this is your stock there.
Okay.
The grinder, we have a pedestal grinder, right? The 2 wheels on our grinder, they're different. The grit is different. So one is gonna actually take a lot more material than the other one, you know. The difference between the pedestal and the surface one, it's a bigger wheel that you wanna actually make. Let's say I have a piece that's square or squared, and I want to change the height of this piece. I can put it there and it goes like, so it tries to actually change this dimension. So after we go between the lathe, the mill, and welding, then we're going to learn how to use the CNC. That's going to be the last one. So the lathe, the mill, and welding, we're going to have that setup, which is demonstration, student 1, 30 minutes, student 2, 30 minutes, then the other day, student 3, 30 minutes, and then this was exercise 1, and then now same S1 and S2 comes again for exercise number 2. So for the CNC, we're gonna come in, we're gonna do a setup of the computer. So everybody's gonna be required to have your Linux computer because you're gonna set up your FreeCAD so you can do it. And then you guys are gonna create the program. They're gonna put it in the CNC, and then it takes like 10 minutes for you guys to come and cut your piece, right? So we're gonna try to do again like 3 different exercises, but then you can come at any time. I only have 1 day there, but at any time you're, can I do my cut right now? Yes. Get in there, you do your cut, and you're fine. So why do we do all the hands-on first and then the programmable later? So we understand the limitations of the equipment, right? Sometimes when we've never done it by hand before, we don't know the limitations, and then we make mistakes because of that, right? A CNC, when it's cutting, it was like, man, this thing is so smart, but it's not. You tell it to kill itself, it wouldn't. You tell it to run into the bed, it would. So you have to know what to tell and how to tell the equipment to do something, right? But the numerical control, if we use a CNC router or a 5-axis CNC machine that's like a made to cut metal, the idea is the same, So that's why ours is not like a huge machine. And you might say the one at Bobcat's like a huge 5-axis, yeah, but the operation is the same, right? Any questions? Oh, I wanted to see like a. So, just something interesting about this machine. So the reason why they're called machine tools, it might be easy to understand why they're separated as one set of equipment. Is that it wasn't until a long time ago that there were no motors that were small. Like for example, if you wanted like a rotating power, let's say you would be by a river and then you have the thing like a rotating for you, or then after that you went to like a big like a diesel engine, so you can get the rotating power. So how would you actually make that big thing, that one big engine, be used on the drill press, for example, to drill something? So what they did was, imagine you have a huge shop. They put the diesel engine here. They would actually loop a belt, and they would have like a shaft, like an axis going to the whole ceiling of the. And then each of the equipment here, you would actually loop a belt into that one power source there. So that's how they were. So that's how you can get like a big engine and just uses a little bit of its power, So that's how it was before. And then much later, then they discovered how to make that big engine into like a small engine. But that's kind of like why these are all rotating based, because they all came from here. They're all using the same setup at once, like one day a long time ago. Not my time, I'm not that old. Right, man, that was quick. Good? Questions?
How is the report gonna work again?
Great
Is
question.
that gonna be after we make the parts?
So we are gonna be working on the report as we go through the classes, right?
Okay.
We're not gonna be like, there's gonna be a day for the report.
Okay.
But when it comes, it's like pulling a Band-Aid, Either it's there or it's not there. So what happened last semester is that all the students, they actually don't put any effort into it. And then gets to the end of the semester, you didn't say anything about the report. So yeah, we've been talking about the report the whole semester, But I didn't go there and say how can I see your report, So now I'm gonna try to baby you guys a little bit more, Grab your hand and say, let's go and look at the report and stuff. So the report, I can, the first part is actually an introduction. The introduction is like what? What did they say that's like what? It's like an operations manual for yourself, right? It's actually how would you operate the equipment, right? So what's something important that you find in the beginning of the operations manual? Safety, good. You remember. So we need safety there. How many things do I have to explain? Everything that you're going to use, right? How many pictures do I need? Anything that you need to point out? Can I use a generic picture? Yeah, you can use a generic picture. Like for example, let's go into the lathe. Oh, that's good. So this is how the module looks like. And it's very, let's say, in the machine shop, if you've never been there, this is your first time, and it's I try to, as if I'm talking to you, So now if you finish your exercise number 1, you're gonna read this, So you know how much you have to go through. But let's say parts of the lathe. Back here. down here I should have on YouTube. Parts of the PDF. Can I use this one and explain everything? Yes. However, it's going to be very difficult to explain. To say, what's number 15 in hour length? Because this is not an hour, it's not the one that we have there, you know, it looks similar. So it's easier for you to say, I'm going to take a picture, I'm going to label 1, 2, 3, 4 on this one picture, and then I'm just going to talk about this one picture. I'm going to take a picture of this other piece. See, like it's easier if you put a little bit more effort, then later on you try to put everything together, you know. So it's easier to do it like as you, because sometimes you're gonna look at something, I'm gonna say this lever uses like this. And then you kind of didn't really understand, you thought that the lever was going to be used that way. So you're gonna write, and then you're gonna say, no, this other way. So like you really know how to use it. Do I need a long text? I'd rather not. I'd rather say, you push this button if you want to do this. If you don't want to do it, don't push the button. Simple. I don't need like a huge blurb, right? And I know that like when it's a, you know, that's the good part. You know, like you can tell when the AI is doing it, because the AI knows a lot more than you guys, you know. So like it has all the information in there. So I want like the simpler the better, because it's your own reference, right? So usually it's easier to have more pictures than to have less, right? And it's easier if you do it as it goes than later on, right? Introduction, and this be like operations. Operations means like what this lever is for, how do I turn on, how do I, you know, have operations there, okay? Then we go exercise 1. And then exercise 1, you're gonna say, we wanted, let's see, modules, project plan, project 1 plan. So this is what we're gonna do in our project number 1, right? So you're gonna add this picture. You're gonna say, we have to get the stock, cut it in the horizontal bandsaw, and make the following part, right? So this is your text here. Then you have, bam, that's the part right there. I followed the steps below to make this part. So you follow the steps below, and what goes here? You're step by step. So you already wrote it, right? It's not that you have to write it again. So your step by step goes here. And then this is what I got. And then it's what? And now it's the piece. You have now you're gonna have the piece that already cut. You're gonna take pictures. You can take one picture. You can actually have a drawing like this, and you're gonna say, yeah, this was actually 0.38. This was like a 2.85, you know, whatever your measurements were. Got it? So that's what you got. And then let's say this piece here was actually 2.65. That's out of tolerance, right? We're going to talk about that next class. Let's say we're 3.0 plus or minus 0.1. So you can go between 3.1 and 2.9. So we're out of tolerance there, right? Why? Why was it out of tolerance? And then you're gonna say, man, like I followed my step, right? My steps were, I got the bone piece of stock. I saw 3. I got my ruler there. I look at where the 3 was. I marked the 3. I grabbed this thing. I put on the horizontal bend saw. I put the blade right there. And then I cut it. Let's see if you guys, how attentive to details you are on my sketches. Why was it wrong? My sketches they're not good, but like they have the problem right there. Who can tell what the problem was?
You're putting the band on the wrong side of the
Yeah.
lines.
The person, so this is 3 inches, right? To the line. When the guy put it here, what's 3 inches? To the line here, right? He put the blade on this side. For sure it's gonna be short. So what he has to say here? Oh, my steps weren't so good. Like, you know, on my steps I should have said, like, you know, I have to mark more, like a little bit more. I have to make sure I'm cutting on the correct side of my marking, you know, because all this, like, we think that this is simple. But like it's gonna be much worse. Like in manufacturing, you have to have like a jig for everything. So it's impossible for the person to make a mistake. Because not that I want it, but like most of the stuff are made where? In China, in India, or some other country that like labor is so cheap, right? Those people, they're working like 20-hour days. So you have to make a jig where the person only has to push the button pretty much, right? The jig grabs and does everything. So like so your steps have to really show what you want to do. Otherwise, you are the one following your own step, and you say, cut it there. And you're going to cut it there. Was it a good step? Not really, because you could even follow your own step. Imagine somebody else, you know, that's working 2 jobs or something, you know. So then you have this part here where it's the conclusion. Why did these things go wrong? And what's the other side of it? For the things that went well, what did you do that it made it to go so well? Right? I was the only one, like between everybody, I checked with my friends, I was the only one that could do this one. Do you know why? Because I double checked this thing. It's good to know, right? So now, we're done with exercise 1. Exercise 2. So, from here, what's all that you had to write? Like, for the report itself. You had to write everything, hopefully, but for the report itself, what's something that wasn't already done? Was the step-by-step already done?
Yeah.
Yeah. So the operations, and you don't have to write the operations all at once, right? You're gonna understand, you're gonna take pictures. Oh, I know how this works. I'm gonna take a picture, write it down, right? The only thing that you gotta do is, this is what I got, and why one thing went well and why one thing went, you know. So these are the two parts that you actually have to write about in this whole session pretty much, right? So we're not going to be redoing the work. We're going to be reusing some other thing that we already done, right? And for your steps, I usually allow you to, you write the steps, you come in, oh, I did this wrong. Yeah, that's fine. Just go ahead and resubmit it. Change it and resubmit it. Right? We're not here to punish you. We're here to educate. So, we punish sometimes. All right. So, yeah. So I added one more day of lecture, so we can actually talk a little bit more about the step by step. And what time is it now? We're done. 45, right? All right. So we can talk about step by step of lecture number 3. So lecture number 2 is next class. So that's gonna be Tuesday, right? Lecture number 3, Thursday. And then after that, then we go for the demonstration day. So again, you can see all those dates on your tentative schedule. Good stuff?